Okay, on this video, we're going to talk about exponents, which might be definitely something you've learned before, but a lot of times there's a lot of properties of exponents and they're easy to get mixed up. So we're going to review these. So the first thing we have to really just agree on is what is an exponent. So if I said, what is 2 to the fourth power? I mean, think about it, it's one of the only math operations that it doesn't really have a symbol, right? Like division, add, subtract. You make a number smaller, move it up there. That means it's an exponent. And what that means is we're going to multiply 2 by itself 4 times. So 2 times 2 times 2 times 2. So 2 to the fourth, if you multiply those together, that was going to give you 16. So if I said I wanted 5 to the third power, then that would be 5 times itself. 3 times 5 times 5 is 25, times another 5 is 125. And, if you had x times x times x times x times x, x times itself 5 times, you could go the other way and write that as x to the fifth. So if we agree that's what an exponent is, you're probably thinking of a whole bunch of rules that relate to exponents. And what I want to try to show you is the only real rule we have to agree on is this is what an exponent means. So that as we go through these properties, I want to show you how you can think about it logically to not have to just memorize rules, but you can actually understand why they work. So the first one we're going to look at is the product property, and that's what do we do if we have x to some power, let's say m, times x to a different power n. And I've been teaching a long time. I've seen a lot of people just try to guess what they do with the exponents, but you don't have to guess. So if we go over here and think about why does this work? So let's use an example. Say I had x squared times x to the third power. Well, what does it mean to square something? We agreed here, x squared means that I multiply x times x 2 times, and x cubed means I multiply x by itself 3 times. And we're multiplying these together, so I have 5x's multiplied together. That, by definition, is x to the fifth. And you can then reason to yourself, well, what should I be doing with these exponents to get this to be x to the fifth? I should be adding these exponents. So you could always make a multiplication problem, write it all out, and figure out what the exponent is. Or this is not going to be easy if these are bigger powers. If you understand how this works, you know you're going to add these exponents. So x to the m times x to the n is x to the m plus n. I add the exponents. So we'll call that the product property. I don't like to call them rules because these are rules sound like things you're just supposed to know and memorize, but all of these are properties that just come from the definition of an exponent. A quotient property. So this would be if I had x to some power divided by x to a different power. What do I do with the exponents there? Let's make up a problem here. Say I have x to the sixth divided by x squared. Again, I'm not sure what to do with these. I could just use the definition of an exponent. X to the sixth means multiply x by itself 6 times, and x squared means multiply x times itself 2 times. And if you think about this, x over x is just equal to 1. X over x is equal to 1. In other words, these divide out to give you 1. And what is left over is I have 4x's together, which is x to the fourth. So then how could I get there from these numbers? X to the fourth is x to the, so this is really x to the 6 minus 2. I subtract the exponents. X to the m over x to the n is x to the m minus n. Okay. Another property we'll call the power property, and that's essentially, what do I do if I have x to a power and then I want to raise it to another power, like x to the m raised to the n? And this might be a good time. I recommend like stopping the video, pausing the video for a second, see if you can make up an example that convince yourself what to do with the exponents when something like this happens. So I'll use x squared raised to the fourth power. And I'm going to start with this exponent. What does it mean to raise something to the fourth power? It means I want to multiply x squared by itself 4 times. That's using this exponent here. Now I could break down each of these x's, but I already know from the property up here that if I'm multiplying x to different powers, it can add the exponents. Even if there's 4 of them multiplied together, this is going to be x to the 2 plus 2 plus 2 plus 2, which is x to the 8th. And so going back to the original problem, how could I get straight to this answer here with these exponents? I'm just going to multiply them. This is x to the 2 times 4. So x to the m raised to the n is x to the m times n. And the next one's sort of built off this. The distributive property, what I mean by that is what if you had like multiple things like x times y times z, and that was raised to the m power. So for example, let's say I have, and I can give these powers too if I want to. Let's say I have x squared y cubed z to the fourth raised to the second power. What do I do, right? I've got to have lots of powers here. Well, for this example, since it's only squared, I could use the definition of an exponent. What does it mean to square? It means to multiply this by itself twice. X squared y cubed z to the fourth times x squared y cubed z to the fourth. These are going to get multiplied. We know when we multiply x squared times x squared, we should add those exponents. So that'll be x to the fourth. Y cubed times y cubed, we'll add those exponents, y to the sixth. And for z, same thing, z to the fourth times z to the fourth is z to the eighth. And if we think about how we could have gotten this answer more directly, or if this power is bigger than 2 and I didn't want to multiply it out, I'm basically using the power rule for each one of these. This x to the fourth can be thought of as distributing the squared to the x squared squared. Same thing with the y cubed squared, and then times z to the fourth squared. And we learned from this property here that we could just multiply these exponents and get that answer right there. So the distributive property means if you have a bunch of things multiplied together inside parentheses and you're raising it to a power, you're going to distribute that power to each thing inside the parentheses. Okay. Let's move on. Negative exponents get a lot of attention because they can be a little confusing if it's been a while. And it kind of doesn't really follow the definition of an exponent. So what I want to figure out is what happens if I raise x to the negative m power. For example, I'm going to use a number now. Let's say I did 2 to the negative 1 power. See, this is a situation where the definition of an exponent doesn't really make sense. How do I multiply 2 by itself negative 1 times? So one way we can sort this out is if we go back to one of our properties that we hopefully agree is true. I'm going to use the product property right here. Hopefully everybody agrees that has to be true. If you multiply 2 x's together, you're going to just add those exponents. So what I'm going to do is make up a multiplication problem with this as part of my problem. So what if I multiplied this by 2 to the second power? According to the product property, what should I do with these exponents? I should add them. That's 2 to the negative 1 plus 2. Negative 1 plus 2 is 1. So this is just 2 to the first. 2 squared, we know is 2 times 2 is 4. And here we're trying to figure out what 2 to the negative 1 should be. Well, this is a multiplication problem, so to get 2 to the negative 1 by itself, what I could do is divide both sides by 4. 4 over 4 is 1. 2 over 4 reduces to 1/2. And the only thing left on the left side would be 2 to the negative 1. And so what this hopefully will be convincing you of is that 2 to the negative 1 is the same as 1 over 2, and I'm going to emphasize 1 over 2 to the first power. Because I could do the same thing if I wanted, for example, 3 to the negative 2, that would be the same thing as 1 over 3 squared, or 1 over 9. So a negative exponent doesn't make anything negative, it makes it a fraction. Okay, I should probably talk about this. What if I had something negative in the denominator? Here, let me use this space here. So say I had like 1 over 4 to the negative 1. Well, we'll talk about an easy way to do it, but if I use what I just learned here, 4 to the negative 1 is 1 over 4. And if I divide 1 by 1 over 4, that's the same as multiplying 1 by the reciprocal. So 1 times 4 over 1, which is 4. So what would be a faster way to do that is if your 4 has a negative exponent in the denominator, you can actually bring it up to the top, right? I could just bring this up. That's the same as 4 to the first in the numerator. Okay, but our definition then of a negative exponent, x to the negative m, is 1 over x to the m. Turn it into a fraction, no negatives. The other thing that can generate some confusion is what happens if I have a 0 exponent? Let's do our example first. Let's say I have 3 to the 0 power. I mean, that's with the definition of an exponent, it doesn't make a whole lot of sense. How do you multiply 3 by itself 0 times? Can't do that. So I'm going to do a similar strategy here, and maybe you can pause the video and think about this. I'm going to turn this into a multiplication problem. So I'm going to multiply it by something and use my multiplication product property and see if I can figure out what 3 to the 0 has to be. I'm going to multiply by 3 squared just randomly, because according to the product property, I'm going to add these exponents. So I have 3 to the 0 times 3 squared is 9. 3 to this is really 3 squared as well, which is also 9. If I divide both sides by 9, then I have 3 to the 0 is equal to 9 over 9, which is 1. And many of you probably already knew that, because you probably thought of it as a rule that a number to the 0 will always just be 1. A number to the 0 is 1. So we could say x to the 0 is equal to 1. Now, I am going to make a little caveat to this, is that x itself, as long as x itself is not equal to 0. In class, what I want to do is show you why that's true. So if I forget, remind me to show you why you can't have that. But any number, non-zero number raised to the 0 power is going to be 1. Okay, there's some other things with exponents that we're going to talk about later, like what do you do if your exponent is a fraction or something like that. But we'll get to that a little bit later. For now, we just want to work on simplifying expressions with exponents. And there's no particular reason for this, but it's very common to simplify an expression so that all of your exponents are positive. And we're going to assume all our variables are positive, which means if you see anything to the 0, we know that's got to be 1, because if it's positive, that means it can't be 0. For example, this one right here. Z to the 0, if we assume z is positive, that means that has to be equal to 1. So this right here is just equal to 1. And anything times 1 is just itself, so we can pretty much just ignore that. So simplifying this is a multiplication. So I would multiply 5 times 2 is 10. X to the negative 6 times x to the 8. This is all multiplied, right? I have parentheses separating, but it's all just a bunch of things multiplied together. So I can multiply these together. add the exponents. So that's 10x to the negative 6 plus 8. We'll simplify that in a second. Y to the third times y to the negative 7 is y to the 3 plus negative 7, which is really 3 minus 7. And then z to the 0 times z to the negative 1 is really just 1 times z to the negative 1, which is z to the negative 1. Okay, let's simplify these exponents. Negative 6 plus 8 is 2. 3 plus negative 7, which is 3 minus 7, is negative 4, z to the negative 1. And then to make sure that all of our exponents are positive, what we could do is turn this into a fraction. And anything that has a positive exponent can stay in the top, but the two negative exponent terms go down to the denominator. And if yes, this is really z to the first here, but that's, you can put a z to the first if you want to. You don't have to, though, because z by itself is z to the first. There would be my simplified answer. Okay, do this one next. So here, you can probably see, well, I've got a quotient, right? We talked about the quotient property and with exponents, and we also have this a bunch of stuff squared, so that's sort of the distributive property. And truthfully, you can sometimes approach these more than one way. For example, I could use the distributive property first to distribute this 2 to everybody there and then deal with it then. Alternatively, I could simplify the inside first before I even deal with that squared. And I think that's what I'm going to do here. That would be, both would be fine, but I think that's what I would do because it's going to make things a little bit easier. So what we could do is this x to the negative 2, since it's negative, is going to go down to the denominator. And as we stated before, if your negative exponent is in the denominator, it could actually move up to the numerator. So I'm going to end up with negative 4. This is going down, so but the y to the fourth is coming up. So that's y to the fourth times y. 3x to the fifth, this x to the negative 2 is coming down, so that'll become x to the positive 2. And then I could simplify using my product property, y to the fourth times y, which is really y to the first, is really y to the 4 plus 1. In the denominator, x to the fifth times x squared is x to the 5 plus 2. I'm going to be squaring that. So this would be the same as negative 4 y to the fifth over 3x to the seventh, all of that squared. Now, a common mistake here, so now we're going to use the distributive property. So that means everything inside here is going to get that squared, including these numbers. And that's a common mistake, is a lot of times people will just distribute it to these, but forget about the numbers. And then the other thing to pay attention to is this square means I'm going to square that negative 4. It's going to be negative 4 quantity squared, y to the fifth squared, 3 squared, x, that's not an x, x to the seventh squared. Negative 4 squared means negative 4 times negative 4, which would give me positive 16. And then we decided a power to a power, we're going to multiply those together. So that's y to the 10th. 3 squared is 3 times 3 is 9. These powers get multiplied. That's x to the 14th. All right. One more. And I encourage you, if you feel like you're getting this, maybe pause the video, try to simplify this on your own, and then come back and check and see if you got it right. All right, so jumping into this one, we do want some negative exponents here. So maybe what I'll do again, there's more than one way to tackle this, but I'm thinking this first term right here, since the z is to the negative 2, I could turn that into a fraction. I could make that move that to the denominator. So that'll be over z squared. Okay, this is my distributive property again, and there's nothing I can really, well, I guess I could move that down, but I'm going to go ahead and just distribute the -3 to everybody. So this is going to get multiplied by, again, don't forget the negative, -2 to the -3, x to the 4th to the -3, y to the -1 to the -3, and then in the denominator, z to the 5th to the -3. Some of you might have been wondering, why didn't I bring that down first and before I distributed it? Well, look what's going to happen. This is actually going to be y to the +3rd. It's going to stay there, albeit this is going to be a negative power, and this is. So again, multiple ways to do it. For now, let's leave this first one alone. But then we'll start to clean up. This is really, well, let's, okay, since this is to the -3rd, I'm going to move it down. So I'm going to have -2 to the +3rd there. I don't want to do too many steps at once. This is really x to the -12, and this is really y cubed, and this is really z to the -15. Okay, so then the x to the -12 can come down to the bottom. Since it's a negative power, the z to the -15th can go to the top. We'll have y cubed, z to the 15th. X to the -12 comes down here. We might as well simplify this. Remember, -2 cubed means -2 times -2 times -2. So -2 times -2 is 4, times another -2 is going to make this -8. Okay, in class, we talked about when you multiply fractions, you just multiply straight across. So I can turn this into one big fraction now. Let's combine a few things here. I have 4x squared. I see I'm going to multiply y cubed times y cubed. When we multiply, we add the exponents. So that's y to the 3 plus 3, which is 6. Z to the 15th. And let's just slide this over. So I'll have -8 x to the 12th z squared. Notice I'm kind of putting the variables under the ones that are in the numerator. Order of multiplication doesn't matter, right? I can move the -8 in front. -8 times this is the same as this times this times this. It doesn't really matter. Well, we can simplify. 4 over -8 is really -1/2. Or we could cancel the 4 and the 8 and leave the negative wherever we want to. So -1/2. Now here's another thing about negative exponents that we haven't really talked about. We talked about dividing, and if I use the division process, the property where this would be x to the 2 minus 12, which is x to the -10. But then if it's x to the -10 here, I could just bring it right back down and make that x to the 10th. In other words, if you think about like multiplying these out, right? X squared and x to the 12th means you have x on the top and you have 12 x's in the bottom. I don't think I'm going to have room to write them all, but you could see that 2 of them would cancel out, and how many x's would you have left over here? You would have 10 of them, okay? So you can, if you understand that, you could just argue that x to the 12th, x squared over x to the 12th, that's going to divide out, and you'll just have x to the 10th on the bottom. Or you can use the 2 minus 12, so that's x to the -10. I'll write it that way, but you can do it either way. Y to the 6th, and here I'm going to subtract the exponents, so that is z to the 13th, but yes, I'm going to end up moving that back down anyhow. So it's -1 y to the 6th z cubed, 13th, I'm sorry, over 2, that's it. Oh, x to the 10th, there we go. Yeah, this needs to come down. Okay, so hopefully you got that, and we'll practice more in class. So thanks for watching. Bring questions to class if you have some.